Hello guys, welcome back to my channel. Today we are going to learn about half subtractor using Verilog code. So what we mean by half subtractor? Half subtractor is a combinational circuit which is used to perform subtraction of 2 bits. And as discussed earlier, Verilog code is the hardware description language which is used for modeling, designing and simulating digital circuits and systems, which we can implement it by FPGA, ASICs and CPLDs and etc. So let's move further. For the truth table, we are going to take A and B as the input, and difference and borrow will be our output. So let's take D as difference and B for borrow. This is the subtraction for the 2 bits. So 0 0 first bit, 0 1 for second bit, 1 0 third bit, 1 1 fourth bit. Now we will do the subtraction of 0 minus 0. 0 minus 0 is 0. So difference will be 0 and there is no borrow. So borrow is also 0. 0 minus 1. 0 minus 1 we can't do subtraction for the 0 minus 1. So we need one borrow here. After taking one borrow we are going to get difference as 1 and borrow as 1 also. Now 1 minus 0. 1 minus 0 is 1 and there is no borrow here. So difference will be 1, borrow will be 0. 1 minus 1 is 0. So difference is 0 and borrow is also 0. Now let's get the expression for the difference and sum. Zero 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 1 1 0 1 1 0 1 1 0. Now let's see where we are getting 1 in the difference column. We are getting 1 here. So the expression will be like A is 0 means A bar, B is 1 means B, plus here also we are getting 1 in the difference column. So A is 1 means A, B is 0 means B bar. This is the XOR expression. So A XOR of B. Now let's take the expression for the borrow. A, B and borrow 0 0 0 1 1 0 1 1 0 1 0 0. Now let's see where we got 1 in the borrow. We are getting here. Here A is 0 means A bar, B is 1 means B. So this is the expression for borrow and difference. So now we will do the circuit diagram for the half subtractor. We will write the expression here for the D, that is difference, which we got as A XOR of B, and for the borrow we got as A bar B. For the circuit diagram we will draw the 2 input lines, that is A and B. We will do for the difference first. We are getting the XOR gate here, so we will draw the XOR gate which gives us the output D. And now we will do for the borrow. We will take the input line from the A, have the NOT gate here which will represent the A bar, and then we will take the B input line. We will AND them together, which will give us the output for the borrow, that is the B. So this is the circuit diagram for the half subtractor. Now we will simulate this in the Eda Playground. Okay, so here we are at the Eda Playground. We'll get this page. Let's do the design part first. First we will get the module name as half subtractor and the input pins we are taking as A, B. The output pins are D, B. So here we will again have it as A, B and output equal to, not equal to, D, B. Now we will be assigning the D value which is equal to A XOR of B, and assign B equal to A bar, which is further getting AND with B. Yeah. Now we will end this end module. Okay, so now we will do the test bench. First we will declare the module name as half sub. The module name for the test bench and the design should not be same. So now we will take register in a form of input as A, B, and wire in a form of output as D, B. Now we will have the module name of design, that is half subtractor, along with UT, that is under unit time, which is used to check the output. Inside it we will have the input and output, that is A, B, D, B, and then we will initialize this. Here dump.vcd, that the VCD is the value change dump, which is a standard file format for storing data in digital circuits, and then dump vars 0 #10 A equal to 0, B equal to 1. #10 A equal to 0, B equal to 1. In earlier class I have already explained what we mean by hash. Hash is the time delay, and here 10 means wait, which is 10 time unit before proceeding to next simulating step, which is to observe the behavior of the circuit at different time points, which will make it easier to analyze the result and to verify the function. Now again, #10 A equal to 1, B equal to 0. This is like giving inputs to the A and B pin, like in a binary form. #10 A equal to 1, B equal to 1. Now we will finish this by using finish. This syntax will terminate the end module. Okay, so now we'll make changes in this part. We have to choose for the tools and simulations Verilog 0.9.7 version, and we have to give run options as open EPWave after run and show output file after run. Give the output file any of your wish. I gave half subtractor here. After doing this, we will save it and then we will run. So here is the output waveform for the half subtractor. So thank you guys for listening to me, and hope you all understood the half subtractor using the Verilog code.